Hey guys, this session is being recorded, and you are on a video camera. You're sharing your screen occasionally. Your audio is being also recorded. I just want you to know. Having said, the last time we did this exercise, which I'm going to share my desktop and show it to you, and this is the segment of the exercise we did the last time briefly. And our goal with that exercise was kind of like this: that we use cloud-based storage service of some sorts, specifically an object store, a place to store items in a bucket. So you put an object in the bucket. That's kind of storage we would like to use. And we chose to use the Amazon Simple Storage Service, which is also known as S3, which is known as, what's going on, my draw pen. Okay, there we go. So it is known as S3. And that is what is a bucket that we will create and then convert that bucket into a website configuration. And inside that bucket, we can put anything we like that we want to become publicly available. That means the read permissions should be read by all, read by everyone. That's a permission issue that I think Tammy is forgot that one step. So her site doesn't show as colorful, or rather as structured from a styling perspective as everybody else's site that has completed the exercise. So it has to be read permissions by everybody and public facing bucket. This whole bucket should be public facing. It gets a DNS name at that time. And that DNS name is what looks something like Slack chat example. Travis has given us this example, lots of you. So I'm just picking up one of those examples here. So let's go see. Travis has given this site. It's called Prawn King something. So that's his bucket name, and bucket name, whatever name he chose, .s3 website .us East 1, which is Virginia location, and Amazon.com, Amazon Web Services. That's the domain URL that he received from the bucket creation. And after that, converting that into a site. What next step that he also did, which is exactly completes the homework assignment, is to use your domain name. So you have to have a name that most of you, I think all of you have. And this name that you have, it can be whatever you like, dot whatever. And so that domain name that you have, this is a prefix to it, and that is the CNAME record that you need to create. And this CNAME record needs to map to the DNS name. And once you do that, you have a proper structured website that looks like not this, but I'm opening a new tab and say www.pantagio. So that is how the site looks like for Travis. He has used his domain name with a www as a canonical name prefix as a subdomain and mapping it with a DNS entry as a CNAME record. And you can see that entry right here. I said dig www.pantagio.us CNAME, and then the answer came back as this line. And that is the representation that you see, which translates to successfully showing www.pantagio.us, whatever that site is, going to the bucket and correctly showing the rendition of that particular page that looks like this. And
there's a catch there, Nilesh, I found.
Yes.
I don't remember that the catch when you showed it, but I wasn't able to get it to work when I had that bucket, that Prawn King bucket.
Mm-hmm.
And I did a Google search and it said you need to have your bucket named your domain name.
Yes.
So when I did that, because I kept getting this 404 not found, and it said bucket didn't exist, and I was like, well, that's not what I'm pointing to, but that's interesting. Yeah, you have to.
So what Travis is suggesting is that your bucket name has to match the DNS name that you intend to use, and that is what you see there, right?
Yeah.
That expansion that you have, the prawn king that you had before, did not work, and that is also mentioned in the documentation, by the way. And I think I did not mention that the last time. You're right. You're absolutely right.
I
This,
might have missed it.
yeah, I did not say that. I know. I remember I did not mention it.
Okay.
And this is the name. It should be structured like this. I may have briefly called it out by giving an example, but I did not explicitly say it. I think that is the issue that I think I had. I did not call it out explicitly. I may have given you an example that went something like dig blog.fungibleclouds.com and cname. So this, did I type something wrong? I think I did. So let's see if that site is still working and functional. Yeah. So I'll recap the whole thing from a repetition perspective, which should be easy. So this site is also structured very same, just like all of us are doing, except there is a subtle difference, which is what I will like to cover today in our beginning discussion, which is content delivery networks. So let's finish up this discussion first of all from the last time's recap. So the recap goes that you have to begin with creating a bucket that has the name that you intend to use from a DNS perspective. For example, www.pentageo.us. That should be the name of the bucket. This is how you are basically communicating to Amazon that is the name that I intend to use. Then you create the bucket, fill it with items, contents, object, and then convert that bucket into a site. And then you get a DNS name, the longish name that you get from Amazon Web Services. And then you map a CNAME record. And once that completes, then your site gets functional by this name as well as this name. That's the core idea. Now we'll do it quickly. We'll go to the write-up here. Where is that write-up? Not here, not here, not here, but here. So that's written down here, static site without servers. And I will now get that virtual machine. I will open up my terminal and make sure that I put this in 50% of the screen, like this. And the other 50% is my website. Now here, I will remove that folder called Octopress completely. And that is gone. Now I will git clone that location, which is what I want to grab from the GitHub location where the software called Octopress will come down. So that is this link. I will grab that software. And so I now have that Octopress folder right here. I will go inside that Octopress folder, and I will, for some of your machines are slightly older for some reason, and I'll tell you what reason. I think the machines that we have in our folder right now, there are two versions. One of them is a June version. The other one is a September version. I think some of you apparently have a June version installed. That is the reason why some of you actually went into and struggled with the gem command. That gem command was missing in the June version. If you are using the September version, you probably don't hit that problem. What I'm talking about is this workstation copies. There are two of them, the June version and the September version. These two iterations of the same virtual machine, they have subtle changes. The Ruby changed, the bundler package was pre-installed. The June version does not have bundler. So small little things are different in the two packages. Some of you are using the June version and others are using the September version. And that threw a couple of people off. So I have modified the lesson itself to add this extra step, which is to install bundler. If it is missing, it installs bundler like this. If it already is there, it will just successfully report that you already have it. That was the step I think threw a couple of people off. So I'm sorry about that confusion, and I will remove that June binary package, OVA package out from that location completely and just keep the September. Or maybe I'll introduce one more. We'll call it October package ahead of time, and I'll load it up. I'll prepare one package and give it to you. So you will basically delete your machine and import one more. So that will freshen up a couple of things that are missing for future exercises. So we'll do that appropriately at a next opportunity. Now, next up here is to install all the dependencies needed by Octopress. So we'll say bundle install. It will go to that location, which is called Ruby gems location. It will download all the gems needed. So it has finished that action. And now we just need to install the theme needed by Octopress. So here is the default theme installed. And you can see those details inside that folder that creates a couple of things. So you can see Atom and open it up, and you can see those things in that location. In the new things that got created was the source folder. The source folder is a new item created. SAS folder is newly created. Public folder is currently empty. This public location is what we will have to fill up. And so we'll just create one sample post right now. Don't have to generate all the 3 posts. Just create one post like this, and then go ahead and edit it. So we'll go to the public location. In the source location, we'll find that source particular first post. We'll call it hello, and then save it out, close it. And next, what we want to do is make sure to generate that newly changed modification, whatever modification we did, hello. We have to include and generate the source code for this and put that in the public folder. How do we do that? We have to basically generate source code for that public folder by going this command, rake generate. And so this may be a little bit fast for a couple of you, but you just rewind and repeat the video. It should be able to clarify the steps we are doing. Let me get to that virtual machine again and the terminal inside, and there we say rake generate. This generates the source code. The public folder will now contain whatever we need. At this stage, we have generated our public folder content, and that folder needs to go in the bucket. So it's a matter of sending it to the bucket. We can locally preview by saying rake preview. Rake preview. And locally watch what we have. So it shows up in the browser, and the browser is opening up right now. Once the browser opens up, I will say localhost, please show me what I got on port number 4000. And so it shows the blog post with a hello mentioned there. And that's exactly what we have. Now, the deviation from what we did the last time, we did not use a name of the bucket matching the domain name that we would like to have. And that is something that is slightly deviating, that I'm deviating right now, because I'm going to tell you that we want to put another layer of another type of storage service, or rather I would say a delivery service on top of this origin. And I'll describe that concept a little bit before we go into actually making use of it. So I am going to get a new sheet of paper like this and deviate from what we discussed in the past a little bit, because I'm going to introduce a new concept that we did not discuss before. And so here it comes, new page. The content, the topic we're going to discuss is content delivery networks. Now, the idea here is as simple as this. So most of you have created a bucket that sits in Virginia location. And so this Virginia location is obviously far away from Singapore location, or far away from Japan location, or South Africa. And so what do we need to do in order for people who are living in, say, Sri Lanka, and get them to access the content of the bucket quickly, efficiently, fast, without having to wait too long for the content to become available to a user who he or she may be sitting in Sri Lanka, and we would like that person to receive the contents of your bucket here in Virginia in the Sri Lankan location as quickly as we can. How do we do that? That's the fundamental idea behind a content delivery network. That's the benefit it provides. So now let's go see an example picture. The picture that I want to show you, I think I have written it down in this location, blog.fungibleclouds.com. And in that location, we have an archive from an old exercise. I think this is from 2012 that I seem to have. The picture is missing. Well, if the picture is missing, no issues. I'll draw the picture by hand. But the details are provided in this blog post as to what do we need to do. Now, in the idea that we are discussing is content delivery network, and here is how it actually plays out in real life. So if you have a bucket somewhere, some kind of an origin location where things begin from, so things are originating from this location, and what you do is provide a cover, some kind of a wrapper around this bucket, and when somebody outside wants to access this thing, origin location, you say, you know what, don't go here directly. Instead, you go to a local copy stored closer to you. And this guy, other person, he or she wants to access the same content from the origin. You said, don't go to that location directly. Instead, you access a local copy stored closer to you. And these local replicas are globally available. And that's what the core idea behind content delivery network is. So we'll now go look at an example. Here is a content delivery network that I currently am using. So I have an account there and I can log in and show it to you as to what it is doing. So if you look at all the locations available from this particular company that I'm currently using as an example, let's see features and the points of presence. Where are the points of presence here? CDN point of presence is what I want to examine in a pictorial fashion. So that's what I was looking to find an image. And maybe this is a good image to begin with. So we'll just pick a random example, maybe this map. And so here, if you look at this picture, you will find that each of these locations has a different point of presence for different people. So like this person in somewhere in a European location has to access the object that is original location sitting somewhere in Northern America. So what this person is doing is accessing the local proximity location, which is a local point of presence for that lady in somewhere in this location. Probably it is France or one of those European countries here. This could be United Kingdom. This could be some other nation in that location. Similarly, the person in India is going to access somewhere in the Singapore location. The person in Australia is going to access the Sydney location. The person in Japan may not have, there doesn't seem to be showing a person, but somebody in Japan can access this point of presence. So all these black colored dots with geographical markers are presented in form of a point of presence provided by the content delivery network provider. And there are lots and lots of these guys, CDN providers. There are so many examples these days. You can see some of them. So let's go keep this picture open in a new tab, go search for CDN, just simply CDN. And you will, no, not these guys, content delivery networks. So we'll see lots and lots of examples of companies that are providing content delivery services, and a good list is probably on Wikipedia. So one of them happens to be from Amazon, another one is from Microsoft, another one from Google, and then there are a bunch of other companies. One of the very well-known oldest companies is Akamai, you may have heard of. Akamai also does the same idea. It has been doing it forever, even before these cloud services came along, is wherever you have original content, the beginning point of content origin, you make copies automatically on demand to geographically distributed locations, keep that available to people in that area. And these kind of services are generally referred to as CDN service. Now let us look at Amazon's example. We are going to log into the Amazon's website, aws.amazon.com. And here I am going to see an example Amazon console, and there I log in and waiting for the login prompt. And password and token, and I'm logged in. So now here we have a CDN service available to us in this section, content delivery section. If you go to the CloudFront section, you will find this exact idea that I'm describing. And there is an example for us to study, but I will look at that example first as to begin with. So what do we have? If you click on this example that I have set already, you will see that there is click. There is a distribution ID. The actual identifier for this particular distribution is a random character sequence. If you now look at the canonical names that I have assigned it, you can assign canonical names right here, like nilesh.loande.com, for example, or blog.fungibleclouds.com as another example. So 2 canonical names I have already called out. This is what I would like to refer to this particular content delivery network by these canonical names. You can have multiple of them. And all the content originally will come from the origin section. Now this origin in this example is a bucket. So let's go look at the bucket. The bucket happens to be this name called blog.fungibleclouds.com. That's the name of the bucket that I seem to have in my S3 location. So you can go to S3 and there you will find in S3 bucket, I seem to have a bucket by that name called blog.fungibleclouds.com. That's where the content is stored. This is basically the Octopress push or synchronize that I did in 2013. And I haven't bothered to touch it ever since. But it's there and it's functional. And that's the bucket that I'm referring to. This has been converted to a static site. This is also the origin. Origin for what? For this. Now, let us go do some dig and figure out what is going on. And we'll do a couple of interesting things to get you a clear idea. So here is our notepad coming up in front. And move it on the side. We'll also open up terminal and move it on the other side. And let's go do some dig. Dig, first one. blog.fungibleclouds.com and say, show me who you are. It doesn't say anything. If you just say without it, it gives you 2 IP addresses, 1 and 2. Is there a typing mistake? No. Yes. And so if you now look at what we are dealing with, this is a custom origin ID. Okay, go to general. So you take this DNS and find out what is its canonical name. And I seem to have some error. So we will not look at this example. We'll create a new one. Something is wrong. I'm not seeing what I'm expecting to see. So I am going to leave this example alone. I'm going to build a new one. What I will do is go back to CloudFront distributions, ignore this example, and let's build it something new, something completely different. So we will first need to have some origin, some beginning point, and use that beginning point to create a new distribution. So click here, and we need to provide a distribution of some sort. So original. I think I must have confused you. So step back. You need to have an origin point which will become the source for all the globally distributed content pushed out in form of a CDN. That is what this will ask us a question about. So you want to select a delivery method for your content. We are going to distribute web content. So we are going to create a web distribution, which will expect us to provide some point of origin. So we'll say get started. And it says, give me the name of the origin. So you can choose an existing bucket that you have, like I have several, or you can select something else that is not in Amazon at all. It may be a machine in your garage. It doesn't matter where it is. It may be another cloud company, but that is going to be the origin. So for example, let us say I have this service called live example. So this site seems to be running somewhere, right? And it is not on Amazon. I know for sure. It runs in the Vultr cloud. So I'll take that name and say, my origin is this. That's my DNS name, like this. There happens to be a bucket also by that same exact name, but we are not using the bucket because if you take the bucket name, it will go like this. with a US S3 Amazon AWS.com, but that is not the origin I want to use. So I'm going to remove this and just put the domain name for my website, which goes like this. And so it becomes a custom origin. It is not an Amazon origin. So it's customized from outside, third party, providing you an origin location from which Amazon content distribution will pull content and send it out globally. Next, I want to choose the protocol that I want to use. So I absolutely want to use SSL protocol, enabling TLS. And I can select to disable one of these protocols if I don't want them. So just keep TLS 1.2 if you like. It's completely up to you as to what protocols you want to choose. Then my origin protocol policy, you can choose whether my origin is insecure or secure, or match whatever the protocol is at the origin level. So if you go back to this example, what we are really trying to do in a fresh case as we build it up is to define an origin location and tell a content what did I write? Origin location. And this origin needs to be provided to this content layer outside. The CDN layer needs to know where the content is originating from. Is it originating in HTTP? Is it originating HTTPS? Or is it originating in a mixed fashion, so that you can mix and match? If it is HTTPS, then you choose that one. If it is HTTP, then you choose that one. But this mixed business is ugliness. I would suggest that you strictly follow HTTPS and don't do these things. But sometimes you have to deal with insecure content. In that case, you choose the match viewer scenario. Most cases, if you have a proper HTTPS secure scenario, you should go with this scenario, HTTPS only, and reject everything else, so that you only select secure content, and that is end-to-end secure. That's the design I would suggest. In our example, I already have it secure, so I can actually go and choose this example to begin with. If you may be playing with another case, you may not have a secure example. So I suggest you take match viewer. And there are some default options here in terms of response. Timeout value for the origin to respond. Origin keep alive value for timeouts. You can choose the defaults as is, don't modify. And then the viewer, the person who's going to view the content, meaning those people that are going to watch your content from remote locations, like global locations, this location, that location, worldwide, they will all be hitting local points of presence for their own content delivery location. So there will be locations in Singapore, for example, in Japan, in multiple worldwide locations provided by the CDN company. And all of them will have a local copy coming from the origin location. That's the origin that we can choose and have the CDN get populated globally. Now the scenario will be something like this. If you have a person in, say, Java or Sumatra that is closer to Singapore, if you will, that first person in Java or Sumatra tries to visit the origin through the content delivery network layer, they will find that it is slow. Because the very first opportunity when you attempt to access the content available in Singapore, which doesn't seem to have an idea about what that origin actually contains, what will the CDN do? CDN will say, oh, look, like there is this person in Java wants to access the content. I need to go to origin location in Seattle, bring it down to my Singapore location, and then present it to this person in Java. That will make it a little bit slow. And that is unfortunately a fact of life. This thing is also known as a miss. It's called a miss, because we are missing the local availability of that content piece for this local person in Singapore location. The next person in Indonesia will find it very fast, because they don't have to go all the way to the origin location in Seattle. The content is locally available for them in Singapore. So they will find it a hit, because they are getting the content available readily to them from the Singapore location, thanks to this first person who suffered through the slowness and is now made sure that the content is locally available to this location, thanks to this guy. And that is what will happen in that region. The other people in Japan, for example, the first person in say South Korea will find that the origin access is kind of slow, and that will be another miss. But subsequent people in Japan or Tokyo will find it very fast because the access is coming straight from Japanese CDN location. So these hit and miss concept is what you will see as things will propagate worldwide depending on demand. If there is no demand whatsoever, CDN will not bother and do nothing. If there is demand, somebody in that region is pulling some content, you need to get that content locally available in form of a cache. And that is the hit and miss scenario that you're looking at. Now, if you continue forward with this scenario and building up that particular CDN distribution that I want to create, and I want to use this content delivery network against the origin that I have, which is my website, I will suggest that you match, HTTPS only in my example case, but for your examples, keep it matched on match viewer, and then proceed with default caching behavior. In my example, I will make sure that the people who are watching are HTTPS only, because I can remain strict and make sure that everybody is strictly seeing HTTPS. Otherwise, they're not delivered anything at all. If they're not watching, they'll get redirected to HTTPS if they attempt to watch just HTTP. So that's the viewer protocol policy. You can keep both if you are mixed content. In my case, I'm going to select HTTPS, and it says setting this value will drop any HTTP traffic. If you wish to redirect HTTP to HTTPS, please select the redirect option, which is a more logical choice, by the way. Redirect HTTP option to HTTPS is a more logical choice. Sometimes users may not actually access http://b.a. They might do it this way without putting the HTTPS in place. In that case, it should automatically logically redirect to HTTPS, and that is what will happen, by the way. If you just hit that link, it will automatically go to HTTPS by itself, and it did. You can see that this padlock came along, which shows you the certificate, and all of that is good, but that is the choice that I think is a more logical choice. HTTPS only doesn't make that logic. So redirect is a better choice. Allow all the methods, and allow basically leave most of these default as is, because it's a good, sane default choices made for you. Now we will proceed through and say, please provide us a default certificate. So that default certificate is what we will receive from CloudFront, and we will proceed forward selecting HTTP2 push capability, which is also recently included in the Amazon CloudFront delivery networks. HTTP2 protocol allows you to proactively push content in anticipation of some content being asked by the end user receiver. And you can also enable IPv6 if you like, and distribution state can be, to begin with, enabled or disabled, your choice. I'm keeping it enabled, and then I will create a simple distribution. So that's what I'm doing at the very top, providing an origin name, choosing it to be a custom origin. It doesn't have to be a bucket. If you choose a bucket location, for example, any of these buckets that I have, and the one that we exercised the last time, this Travis MSDFDF bucket, we can choose that bucket, or choose a custom origin, which is not a bucket, not even in Amazon Cloud. So those two choices are available, custom origin or a bucket origin. If you happen to have another thing somewhere else, you can just put that as an origin name and proceed through. Most of the defaults are good defaults. And at the end, you have this button to create a new distribution. What it does is prepares itself to make that central origin location content globally available. And it is getting deployed in progress. You can see that progress symbol happening right there. So this is going to be preparing itself to globally replicate this particular content that I have in the origin location and take it worldwide. Now let us see some of the things that we have received as a consequence. We've gotten this thing, this DUU, whatever this thing is. And if you go look at that, we will find what it actually does for us. So if you now take dig again and put this on the notepad on one side, we have this thing from CloudFront. We began with an origin location, and then we created a CDN that looks like this, line number 11. That was our origin. Now let us go examine what is line number 11 do for us. So we'll go dig and find out. It shows you an A record. Now we'll go see dig and ask for something. I'm expecting that output is not visible. Maybe it is still propagating. Yes, in progress. Yeah. So we'll have to wait for it to propagate and make itself available for us to be able to do those dig queries. It is not ready for us. Give me a second, dig. Yeah, we are able to find it now. Let's go dig for this thing. That one is broken. Not yet, not yet. This one is still, this DUUNX is still in process, is being deployed right now. In the meanwhile, I think we can explain another concept which will help us understand this global distribution in a much more sensible fashion. So I will go back to the previous example, which is currently deployed, and play an example dig command on that domain, which is provided for that different distribution, the one that is currently deployed, that one. So we'll take that distribution, the domain name for that distribution, and put that in a different example. So let's say here, and this happens to be a bucket. So that bucket was the origin, and this is the CDN for that example that was already in place. Now, if you take this CDN and open it up in dig, what do you see? You see dig and domain provided by CloudFront, and ask it for its A records. And you see there are 8 or 9 different points of presence available to us. These IP addresses that you see as a collection response coming back to us from dig is an indicator of all the global locations that this particular content delivery network is available. So in order for us to let our end users access the bucket that we have as the origin that we have, without going to the bucket directly, you have to somehow tell people, hey people, you go to line number 10 instead. But that is very difficult to remember. So that's where you put in a CNAME record. And you say, you know, my CNAME, blog.fungibleclouds.com. You go as a CNAME alias to this line number 10. So now if you go do a CNAME for this, I think that CNAME is probably broken. So I need to go and fix that line number 15 CNAME alias to line number 10. That is, I think, broken, which I think I need to go and fix in my account. So that piece is broken. I need to go and correct that scenario, which means I need to go to the DNS control panel for this domain and put in an entry like that, or identify what may be broken. It should actually give us an answer saying line 15 is mapped to this location. And then that location number 10 is mapped to the bucket itself. So that's what I'm going to examine first for this CNAME record. Is it in place or not? I'm going to go to my DNS control panel for that particular domain and find out what do we currently have in there. So I'm going to log in and go to this Fungible Clouds domain, look at its DNS, and then, aha, there is the error. So the error was that I have somehow accidentally clicked the orange box. That I'll tell you more about what that thing is. It actually overtakes. And so I need to remove the orange thing like that. Now, that was probably a fat finger at some point. And so I have to wait for this for 2 minutes. So let me go and adjust that for a 2-minute period and freeze. And that was an accidental mistake I must have made at some point. So I'll tell you what that mistake was. But now I will wait for 2 minutes for this to propagate. Now I have a CNAME with the name blog under this domain called fungibleclouds.com as an alias, CNAME alias for D2H7G34, whatever that thing is. Now, what is that thing? That thing is exactly what I have been given as this thing. right? D2H7 is the domain name provided for the origin that I have already, as an example, already deployed. The second one is in progress. Now let's go dig again, and it should give us, in matter of 2 minutes, that correction should happen. So we'll wait for it to finish in 2 minutes, since I updated my DNS entries, and I should, where did that go? Search for the blog entry, and it is in next 2 minutes should show up this as the alias, CNAME alias should populate just like I expect it to be here. So I'm expecting dig CNAME should show us line number 10. And the origin name that we have in the original bucket, let's go look at that as well and finish that discussion from that first exercise perspective. We have our origin defined as this location. So we'll copy that and put that in the notepad here as the origin. Now let us go do web searches, simple links on websites. So the first one I'll open is line number 7. Whatever I have in 7, I'll take that and open it up. It is hitting the bucket directly like this. And you should see this website that I have. It is coming straight from the bucket. Now, next I will take line number 10 and open it up. And you should see that I receive the content delivery network representation of the same bucket like this. Line number 10 coming up. And you can see at the top, it is D2H7, whatever that I have there. Next one, I will take this representation, which is the friendly representation of line number 10, and I'm expecting the same result. You will also notice some performance differences in between the two. Between the first one is going to be slow, a little bit, you cannot really notice, but I'm going to paste all these links for you in Slack chat, so you will get to feel them on your own and play with them a little bit on your own before we proceed our discussions. Here are the links that I'm using right now. You can actually play them out right away. And what we are doing from a summary perspective in this discussion is line number 7 represents the bucket. Line 10 represents the CDN representation provided to us by CloudFront. And line 14 is a user-friendly representation of 10. That's what we have in place. The dig query was not responding because of my fat finger here. And I modified that. So now dig should respond. And I'm going to clear it up and say, dig, show me. It still doesn't respond. Okay, well, we'll figure out what's going on. Can you check, one of you check if this dig is responding to you? The dig command that I want to run is this, line number 14. I want to see line 10 in the output of line 14 dig. So please try this command in your terminal, in your location. It should say dig, this domain name, followed by CNAME record. That's what I would like you to run and tell me the output you receive, because I'm not receiving as I expect it to be. I'm expecting line 10. I don't get it.
Yeah, I just got it.
What do you get?
I'm getting that D2H7G30.
Oh, you get line number 10. I see. Okay, so that is something wrong with my local DNS. So this thing is actually functional, that means. So now I want to help you understand the idea behind this thing. If you, this thing being, somebody posted something. Oh, you got the response. Brian says, Brian is giving us a response with the CNAME output showing up correctly, and I don't seem to get it for some reason, which we'll deal with later. But you got the CNAME output, which is basically mapping line 14 to line 10 in form of a canonical name. And 10 is a globally distributed network. Let's see that. We saw it already briefly. Let's go do it again quickly here. We'll say dig and that name and give me the A record for that. You get 8 entry points. All these 8 points are globally distributed. They are the representation of line 19 through 26 are different IP addresses globally spread out. This is what is driving the content delivery pointer presence for my bucket in line number 7. Line 7 is that bucket itself, as you can see in right there. The bucket that I created happened to be sitting in US East 1, Virginia location. and it is globally propagated worldwide. And this is the core idea behind our content delivery network. Now let us go see some hits and misses. So we'll go to Amazon again and close out these unnecessary windows and focus on some of the results of hits and misses and statistics accumulated over the years. I must be able to show you some cache statistics. So here are statistics for that particular specific distribution. Which one are we looking at? This one. No, not this one. This one. That distribution is showing us our cache statistics for a period of, let's say, last couple of years. And so let's go say January 1st all the way. Come on, I want to click. But it doesn't want to give me any longer period or what? That will be lame. I want to say, let me type by hand, but it doesn't. Okay, let's go last few days. Let's go see last 18 days what has happened. In any period in the previous 60 days for all viewer locations, you can see statistics of caching for that particular CloudFront provided to us in a visual form. And this bucket, this CDN that we're looking at is this one, not the one we just created, but the one that has been in existence since 2013. So if I update that, I see some recent statistics. I see that the total number of requests are in like very low hundreds. So nobody actually visits this site, and it's not a popular site. It's probably nobody cares, but some of us do. So we visit, and there are 600 hits on September 3rd for some reason. 542, and the hits are coming down, and these are total number of requests. Now here you see the interesting hits and misses combination. Green items are hits. Most of these are, a large majority are hits. Some are misses. The blue ones are misses. So you see the blue numbers are 58 miss. Here we have 55 miss. And so here we have 50 miss. So sometimes we see some miss actions. And the red items are apparently errors. And I don't know why the errors are, but there are some errors. It seems that somebody is trying to access something that doesn't exist. That will be treated as an error. A 404 will be an error. So sometimes people will want to hack this website, assuming it is something else. They will assume that there is a database and a login and a password, but there is nothing. It's just a static site. So people will attempt to hack this website, assuming it is a WordPress site or something of that nature, and attempt to do that hacking. As a consequence, they will see these errors because there is no such thing called a login page because we don't even have it. That's the reason why we have these errors. They're not really errors as we expect them to be. Next, you see some traffic transmitted. The total number of bytes transmitted are very low. Like it's like 11 MB on a given day, and all the way up to, let's say here was how much? 13 MB. So it's a very low traffic site. And this content is transferred straight to the viewers from the point of presence locations that we have identified is these lines, number 19 through 26. Those are the globally available points of presence that we have been able to use thanks to these guys, CloudFront. And how am I paying for this thing? Let's go find out how much do I actually pay for this CloudFront service. Since there is not much usage and very low activity, my bill is tremendously low. Let's go see that. My billing dashboard, I think I pay like 1 cent or something on an overall basis for this CloudFront activity. So let's go see my CloudFront portion of the bill is how much? It's 24 cents. There we go. So here we have 24 cents in the last month to date. But over the years, I've been very, very low in consumption of my CloudFront because nobody visits this website. It's very esoteric and not super interesting. But I have put it in place for this exact exercise example is to allow us to discuss this idea is that we can provide a layer like line number 10, which is a globally distributed multi-point location, multiple points of presence representing line number 10, which covers and provides a wrapper around our point of origin, which is line number 7. And you can put a friendly name on top, which is line number 23. You can put another friendly name on top, which I have by giving a second CNAME as another friendly name for the same thing. You can see this another friendly name opening up exactly like that. and DNS is broken again. But I have not been playing with that domain much. So let's ignore that 24 line completely. But if I fix the DNS, it will pop up and show up the exact same content. Now, next idea. This origin doesn't need to be a bucket. It can be anything you want. Something like www.pantagio.us. It can be like that. Or you can basically modify the way you want. And here you can say, this is going to be my own canonical name, the CDN front end dot pantagio.us. You can convert it like this and put in a content delivery network line number 10 in between, which will make global points of presence worldwide. And you represent that as instead of this Pantagio, I should say .es3 website .us east 1.amazonaws.com. That's what I would suggest that you use. And for line 23, www. So if you convert it like this, introduce a CDN layer in between and map your line 23 to line 10, and 10 is the wrapper around your origin, then you will get a high performing site for cheap. I mean, this is how everybody is doing it. Big boys do the same way. You will see this everywhere along all the big sites working like this. They will change the content delivery network, may not use Amazon's content delivery network, may use their own network or use Akamai or somebody else, that like I use Key CDN. But there are lots and lots of content delivery network solutions providers available like this. You can just put your CDN in between and off you go. That's the basic idea. So you have a small, tiny little server somewhere. It doesn't have to be a bucket. You put your CDN and make it globally available magically. And you pay, let me show you exactly what I actually pay. So to a production scenario, which is what I use this site, which is another CDN, I'm going to log in and grab my token before I succeed in login. So where is my token? There. And the token, please copy the token, put it here and log in. So I think I logged in. So you can see that my expenditure that I gave, I think was like $50. So I spent $50 for the whole year, and I have spent something like, $59 or something. No, sorry, 59 cents. What am I saying? 59 cents I have spent because I began with $50 credit. I am at a 49.41 credit left. I have consumed in two different zones. There are two zones that I am using. If you look at my reporting and analytics, you will see some consumption patterns of that content delivery network. Total traffic consumed by the website BA Cloud Genius happens to be on a global level, 175 MB. It's a very tiny little traffic. I'm not actually, when you watch videos, they don't come to you from the Cloud Genius website. If you did not know that by now, they come from another service. If you watch whatever you do that is heavy lifting, it is not coming from that box that I run in the cloud called Vultr. Instead, all the heavy objects are coming from some other places. Sometimes it's a YouTube video. Sometimes it's a Vimeo video. Some other places I will have a special network that I run to give you virtual machine, that OVA file. It's like 2 gigabytes, right? This is how much traffic? 175 MB. And that is for today, I think. September 18th. So it's not that big a traffic. And cache hits are pretty decent, 77.14. These are hits globally. So anybody who's hitting from globally, any locations, I'm getting a good amount of hits and good success in terms of caching, which means my server is not bothered, not bogged down by people hitting it too hard. So I can get away with a cheap server. I'm not kidding. I'll show you how much I spend on the box itself. It's literally a tiny box, but supported with global network like this. And there are some client errors that I can find out what that error was, and we'll deal with the errors later. But bottom line, There is some patterns of traffic. There is cache activity. Caching is actually helping me because there are lots of cache hits. You can see some real-time statistics and real-time logs. If you happen to hit, they will pop up. If you happen to hit website, these will actually show you whether it's a hit or a miss as we go along. Most of you have been using this website all, for the last few days quite succinctly, so you can see that you will all be having hits and you will probably not see much miss as such. Geographically distribution, my geo distribution is most of it is US and some in European countries and these parts of the world, but it's mostly US as you can expect to see, and those hits is what are showing up in a geographical distribution of the content provided by this content delivery network. Like these guys, there are many more providers and big players like Amazon and Google and Microsoft and Akamai. All of these guys basically have the same idea: multiple points of presence, like here, like I mentioned, multiple points of presence showing up like this, and you wrap your site around with a content delivery network. Make your content far available, far away from your location. Now, one more example on this topic before we change. That is, we'll go to this site and look at my picture. And you carefully look at this picture. It is me, but more importantly, let's look at the image address. So copy image address, and let's go see what that thing is here. Now you carefully watch the URL. You see line number 12 is not my website. What is it? It is not b.a.cloudgenie.us. It is something else. Can you tell me what that thing is? My site is this. So what is line number 13? I think I gave you the answer. The answer is it's a content delivery network. And let's go see where that thing comes from. So c.cloudgenie.us, what is it? We'll dig. And it says the answer is this. What is that thing? Line number 13 is actually this. What is this thing? It's KeyCDN, that site that I just showed you briefly. That CDN network that I have put in place. So for every single thing that you see here is every single heavy object, meaning whether it's a picture or whether it is a CSS file or whether it is a JavaScript file, they are all coming from the content delivery network, not from the box in line 8. Line 8 is the box, which is small and tiny and cheap. Line 13 is the CDN representation of the box, of the items in the box that show up as, let's go see the same exact item directly visiting the box. So this item that you see, line 11, is the CDN representation of my picture. That's what is showing up in the browser, and I open up here, it shows up the picture. Great. Now you can see the URL at the very top is c.cloudgenius, line 11. Now I will actually visit the origin location, b.a. This is slightly different between 11 and 13, two different things. 11 and 13, very subtle difference. 11 is CDN, 13 is the box, number 8. Let's go directly to the box. You see the same thing. But this is hitting the box directly. I want to not hit the box at all if I can. And therefore, I'm putting a layer of CDN in between. What am I doing? I'm taking this object, line 9, putting a CDN on top, the KeyCDN network to be specific, and providing line 15, and then using that in my HTML. And there is some code that is needed to make that happen, but that reduces burden on my machines. And that's one of the ways you can use to offload work on your boxes. And now a key point to remember. The point to remember is like this. If you have a bunch of machines in your cloud, you would rather keep all the thing that you want to preserve for long term, like pictures, assets, files that are user uploaded. You want to keep them outside of these boxes. That's the whole idea behind discussing this storage as a service concept. Is if users are uploaded, let's say for example you upload an item to Facebook, the picture that you upload, and it needs to be stored outside of that computer that you have in the central location in the cloud that you have. You want to keep that asset outside of the servers, and by doing that you gain one big benefit. That is, you can now treat your servers like cattle. You can shoot it and create a new one, and that is a super benefit of having the ability to keep your relevant data outside, relevant state of the user outside of the server. So you can then randomly shoot machines and create new ones, and they will scale and grow and shrink on demand as you need without wasting too much money, because your real valuable assets are kept outside. Now we'll draw a picture, and here it comes. The picture goes like this. Let's see if I can get my pen working again. And where is my picture? File, open from recent, here. Organizer, this one. So you have, let's say, if a pen is working, not yet. Come on, pen. Yes. So let's see. I'm going to build our own Facebook, for example, and we have these people, right? This is me and my neighbors, and I take a picture. I take a picture of something, my dog, for example, and I say that, what, I am going to use my camera and use that picture of my dog to upload it to this site. And since this is a load balancer, what happens is I get assigned to one of these two boxes I have, either this one or that one. One of these two I will get assigned to. And so this is me. I upload. I hope you can see the screen, right? Yes, you can see the screen. So this is me uploading a picture that I take of my dog, upload it, and I seem to get assigned to this box here. So I send my picture, the picture goes here. So this is the picture P. This picture shows up. And I take it here. P picture goes all the way like this and sits here on the box. Now my neighbors come along and say, hey, we went to our home and we tried to see the picture that you took. And we also went to the same website, and that load balancer decided to assign us to this box. And I don't see any picture. Where is the picture? That's the question, right? Where is the picture that you uploaded? This picture P, it was here and we saw it on your computer, but when we log in from our home desktop, I don't see the picture. What's wrong with this site? That is the problem that I think we should be able to solve. We can solve that problem simply by making sure that we do not store at all. That picture should not be stored at all on these computers whatsoever. So where do you store them? You store them outside in a bucket, in a separate service. You can keep it wherever you like, but it's a separate, completely different service. And that is what I'm talking about. In the example we are choosing is Amazon Simple Storage Service as one example. And in here, I am going to upload the picture again. So I'll say, oh, take my picture, and it goes there. And the code here should actually not store the picture here at all, not here, but instead say, I will move this picture to a bucket in the Amazon Simple Storage Service and get the link to that picture and make it available in my machine. So by doing it this way, the picture actually goes here. And when it's there, it is accessible directly and directly like this. It's a separate service. It doesn't go through the load balancer at all. A completely directly separate service available. So it's not going through the load balancer as such, which means I should not draw it like this, but instead draw it like this. Now the picture is sitting here, which means now I can shoot my cattle comfortably. What does that do? Or maybe I can grow my cattle if I like. So if I want to grow my cattle, grow my number of machines that I have, I can completely easily grow them like this. And all of them, more people, more users will come along and they will all be able to access the same item P, because it is not even stored here or anywhere else, but in the storage service, separately managed, globally available, highly durable, and reasonably highly available. So you want to use those services available outside and not your boxes that you are managing. That's one of the ways that you should use these services, is to offload any state that you want to keep, the user generated content or any user state of the user should be kept outside of these boxes. And if you succeed in doing that, you have a nice little cloud that is not so expensive and it scales nicely, and you can grow and shrink along with number of users comfortably. That's the purpose as to why we do these things, to keep it separate. So the point to remember here is maintain the state of the user outside of your machines, outside. And by doing that, you get the ability to basically get rid of the machine as and when you feel like that. You can delete your machines, no problem, and keep shrinking as you need to and save money because your content is sitting here. And it is also very cheap. It's not super expensive, as you know already. Pricing is very decent. So that's that idea. Now, closing out on this topic, this key CDN thing that we have here, c.cloudgenie.us, is a different site. So let's go see what that thing was. You already saw that here. You dig that thing and it came up with the key CDN pointer CNAME, which happens to be another CNAME alias, which happens to be going to this box location somewhere. I don't exactly know where that location is for our geography for Seattle area, but what I know is you can test key CDN's point of presence globally and actually identify. Let's go see if we can do a key CDN test. There should be a testing tool available. So here you can go and test out and find out where the learn ping test, performance test. There are lots of tests available that you can run through. So you can say IP location finder test, ping test, or run all of these tests on your own at any CDN, against any CDN. So let's go quickly do a quick test, site speed test. So I'm going to put that link here, b.a. and test it from a variety of locations and say run. You can choose the location you like. So I like to run it from Seattle and say run. So it'll test this site from a global points of presence as to what is the response time for a user sitting in Seattle. It'll hit all the points of presence locations for that particular site and give me a report as to what that timeline looks like from a asset by asset perspective. So all these assets which are included, for example, there is this JavaScript asset that you can see here. So this JavaScript that I seem to be using in the site, let's go copy that link. This seems to be one of the minified versions of a JavaScript file that seems to be sitting there. So it is kind of sort of like, a link we have that shows up actually as a CDN value, this, and corresponding to that should be a direct value with line number 10, modify by hand, b.a. And that's the modified value, line number 10, which is hitting the box directly, as opposed to going to line 18, which is through the CDN. So every little item for HTML, CSS, JavaScript that is originating from the box is provided by a content delivery network like line number 18, but it is actually originally available right here in form of this JavaScript that you can see that I just showed up. I pulled up directly from the box. You can also pull the same JavaScript from line number 18, which is the CDN representation of line number 10. The same thing will show up like this. New tab, open, CDN coverage. This will be delivered to a user quicker, faster, because it is coming from a close by location. Proximity is lower, smaller. So it's closer to that user, wherever that user is. That's the core idea behind our CDN. So you can see that, if you go into details, every single element in that site is actually getting rendered by a content delivery network. You can see the logo, this picture of me, picture of Mukesh, and things of that. All of these things are C dot. You can see that consistently, and you can see details about how much the response time is, what is the, I'll go through exact details of all these things at a later time as to what they mean and how do we put that to use in real practical projects. But here is the actual logo. And this representation is the logo.png coming from the source location, origin location, b.a.cloudgenie.us, which is the box that I have. And this logo representation of the same thing is coming from c.cloudgenie.us, which is the content delivery network. So simply another example. Sorry, this goes here, and this goes in form of C dot and with a S loaded. So that's the concept that we just discussed. Now we have started a new CDN for ourselves as another case that we were experimenting with. We should go and see if it has propagated or not. I think it must have propagated by now. And it deployed and enabled. So this site should also do the same thing, like exactly the same thing. So let's go check that out. We just created this new one, if you remember, just a few minutes ago, a new content delivery network with an origin of b.a. and it has successfully deployed and enabled globally at 9:18 today, basically today at a few minutes ago. So we should be able to take that URL and identify in our notepad. I have a different CDN now with this name. So I should be able to predict that I can access my logo picture pretty much like this. You see line number 24, I just made it up. Because I know the name of this new different CDN, I made up my line 24 by hand just in front of you. And I'm going to go do a quick check as to what do we receive. So that is the logo representation, the picture of that this item, basically. Line 11 is represented by key CDN in line number 19 and is represented by a different CDN in line number 24. And you saw me how I created line 24, basically by taking line 11 and modifying the link using the one that we have been provided to by this different CDN, which happens to be Amazon, that we just deployed like a few minutes ago. I will now take that link. And so this is the first time I think anybody's going to hit that new CDN at all, ever. So because nobody has hit it yet. So I will hit it. How do I hit? I will rather not use a web browser, but instead use a command line and hit that thing in a command. So you can see some characteristics in much more, detailed fashion. So here we go. It says miss from CloudFront right there. You see the miss. This was miss from CloudFront because this item was not available in the CloudFront. It's a fresh new deployment. Miss. Now we do the same thing again. And we say it'll be a hit. This time I'm going to show you, and it'll show you a hit. Right now it shows miss from CloudFront. I'm going to run the same command again, or rather let you run the same command again. That's better. It'll be a hit this time. I'm not going to hit. I'm going to leave it alone. I'm going to paste it in Slack chat and let you hit. So you can see the hit success. And that is coming up. The command is coming up for you. Oh, what did I type? Not this. I should type in curl-i and then the command. Off we go. So type this and tell me the output. You should see a CloudFront hit. I see a miss because I was the first user trying to access that object called logo.png in this location. And I'm going to hold on and let you see what the response is, and you should see hit CloudFront, and tell me that you see. You should see a hit. That's the characteristic of any content delivery network. The first user is going to get a miss. Any subsequent user in the same geography, you will get a hit and a faster performance. You can even measure how much time it takes for that item to show up in a curl, this is a header. This is called a header check. By the way, what we are just doing is a header check. We are checking the header for the item that we want to load up in a browser. So it comes along with lots of other things. One of the things is a cache hit or miss scenario. So if anybody did this, let me know the output in Slack chat so we can all see it. And so Brian says he got a hit. Thumbs up, says Travis. And so that's beautiful. So what you're doing is you got this idea clear that we just started a new content delivery network with our origin as the website that I have. I used one of the asset elements in there, this logo PNG, and I attempted to access it through command line deliberately to be able to illustrate this point of being able to see the hit and miss details, which we saw. I got a miss, you got a hit, good, I'm happy. So that is the concept behind this content delivery network. Now, how do we put this to use? Let's see, another John Beaver also got a hit. That's nice. And now let's see how we can put this to use. By the way, CDNs are cheap, apparently. Don't get mistaken. They can be very expensive. How they become expensive? If you get lots and lots of traffic, they are going to be expensive. CDNs are not cheap, don't get me wrong. Content delivery network can burn a hole in your budget if you're not paying attention. So be very careful. It burns a hole when you have lots and lots of traffic. So you have a new product and you go show up on Oprah. Yes, you will get hit with a big bill. But no worries, because your product is going to sell. The good thing with this content delivery network business is that your site will not go down. It will be protected by a global network of giants helping you out. That's the benefit. That's the reason why people use it. Is, even if you get a hit, a lot of people hitting your site and services, you will survive. It's not like your site is going to crawl to death if that happens. So that is something that is a benefit to have, and therefore you use it very judiciously in a fashion that you monitor its usage and don't overspend beyond your budget. And it's typically used by businesses, not individuals, but you can use it as an individual, no big deal. Even if you use it as an individual and you have a small budget for a personal project, it is affordable because you don't have too much traffic. And if you get traffic, you're not really an individual, you're a business at that case. So that is also okay. I mean, just understand that it is not strictly cheap solution. It is an expensive solution if you're really, really using it, because people will be hitting your services. Not your site as such, not the box itself, but your overall services will be hit. And hit means somebody is taking burden off your box, which means you have to pay them money. Bottom line, that's the bottom line. So we just used one type of distribution. I just showed you one, which is called a web distribution. There is another type of distribution, by the way. It is called an RTMP distribution. And that distribution is the second choice right here. I don't have a quick way to demonstrate because it requires live video. And I can give you an example of what I have in place already, but it is not going to be a new creation like I just got started and created a new distribution just like that in the matter of 15 minutes or so. We were able to complete that exercise. That is not going to be possible in a video distribution because I don't have a video source to give it to. So, but I want you to know that there is this other type of distribution called RTMP distribution. RTMP is real-time media protocol. What it does is basically streams content. So there is more chat coming up. Hit. James says hit. Nice. So by the way, let me give you examples of miss. So anything that you see in some examples of miss, what you can go is go here and find out pictures. Right click on them. Like let's say this guy, right click on him and copy image address, modify the URL and include this DUUNX, whatever that, cloudfront.net, and you can see a miss for yourself. Unless somebody else hits it before you, then you will see a hit. The first person does it will see a miss. Okay, now we're talking about the second type of distribution in a CloudFront setup or a content delivery network setup. That distribution, simply speaking, is not dealing with static content. Like these files I mentioned here, like this picture or this JavaScript or this logo, they are what they are. They're not changing like rapidly on the minute or the second. Every second, the picture doesn't change. It is going to be the same. I will become old only after so much time, not immediately, right? So the picture will not change, and so the picture is what it is. That's what a web distribution is useful for. But when you have a live video or something like a camcorder or an iPhone, you take a video and you have to make sure that video flows out all the way to some audience. In that case, you typically transmit, like, by the way, like I'm doing right now. Hey, this is me. I'm showing my video to you, right? That's a live stream happening. You cannot really tell what is going to happen next. Nobody knows, right? That's live. It is not a pre-recorded session that I'm playing at you. So that kind of a distribution is called RTMP distribution. It uses Adobe's media protocol, which is Adobe Flash Media Server. And that is the underlying protocol that is also available in a variety of clouds. The underlying protocol has been reverse engineered and is available in the open source domain. I use this technology in one place. I'll show you where it is. And let's see if I can actually pull it up. Okay, where is that? Let me see if I have it handy as a quick demonstration for RTMP. Give me a sec. I'm looking up an RTMP endpoint if it is hidden and available. If it is there, I should be able to quickly demonstrate to you something very interesting. But let us see if I have it. Rebroadcast. Let me check. Yeah, I think I do. Okay, I have a demo for you. So let's go. On the front page of our site, there will be a place to broadcast live video, and you will see it coming up. I just enabled it. So I will now go back to the front page. And here you will see a new item that shows currently nothing because nothing is broadcast. And I will now show you where it is. It says next stream starts in 35 minutes or so. I just added a new piece of content on the website. You can also see it, by the way. And what I'm going to do now is take my iPhone and live stream my laptop to you through the phone. So here it goes. I'm going to start a software on the phone here and stream it to a streaming media endpoint, which is also covered through a content delivery network like that. So here is my laptop, and I'm going to start broadcasting. And here I go, started. So I'm broadcasting right now. You are looking at my hand, and you're looking at my laptop, and that's what you will see. It should show up in this window right here. And let's go see that. You should also be able to see it right now, right? By the way, it says we are on air because I just went online. You can also see it, by the way. And I'm going to play this video. There we go. You see that? It is live stream happening. You should also be able to see it right now, right? By the way, it says we are on air because I just went online. You can also see it, by the way. And do you see it? Any of you? Do you see anything like that?
I can see it. Mm-hmm.
Yeah. So this is live streaming happening through my camera on the iPhone, streaming to my site. Now let's go see how this technology is implemented in form of a content delivery network. I'm going to shut that stream down. So I'm shutting it down. Shutting it down right now. Do you see anything like that? Yeah, okay. Yeah. So this is live streaming happening. Okay, let me shut this up. Okay, yeah. I just disabled it. But let's go see what's going on. Under the hood, we are using a protocol called Apple HLS, HTTP live streaming. This live streaming example is the software that Apple has developed, and that's how they broadcast their live events. The Apple event had happened on the 12th of September, happened like this. This protocol is built into Macintosh and in Windows Edge browser. to be able to show this to a user, like I showed it to you here, requires RTMP protocol running on the back end in form of a media streaming server that you can either spend money and get Adobe Media Flash Media Server, or you can use Nginx RTMP. Nginx RTMP. So this is an open source product, which is basically a reverse engineering of the Adobe product. And that is what I have implemented in one of the, how do I describe it? One of the Docker containers running in the backend on the same box. The same tiny box, by the way, is running this. You can see a quick example of that here. And you will see some streaming activity. If I start it again, you should see that. Let me start it again. So you should see some activity in this this location right now. So where is that server again? Here we go. And start that activity again, and you will see some streaming activity and some CPU consumption bumping up immediately. And here we go. I am starting to stream now. My hands, you can see that this red item popped up is showing you CPU consumption growing because I'm streaming right now. And these items will go down in consumption right there as soon as I stop streaming. So I'm going to stop now. It will slow down. The CPU consumption will go down. And you can see it going down in just a minute. It went down. Now, what was going on under the hood? I'm running this software, which is Nginx RTMP, in a container on the back end. Now, I'm taking that output from that location and putting it back with KeyCDN. Again, KeyCDN also provides me with that kind of a video streaming solution like these guys do, RTMP distribution. They also do the same thing. I'm just using KeyCDN solution, and you can see that the setup that I have has two zones. These two zones, one of them is the object delivery, of picture delivery, JavaScript delivery, static objects, content delivery network, web distribution. The second zone that I have is actually labeled slightly differently, and it is called H. The first zone was A. The name I used is A, and the other one I used is H. H for HTTP live streaming. And it is basically going through this URL, http://hls.cloudgenius. And it is structured like, if I go to Manage tab and Edit, you can see that it is structured like a advanced feature. And there are too many things to deal with in these setups. So there it is, optimize for HLS. So I have enabled that particular zone as an HLS front end to the back end RTMP server that I have put in this product. So let me draw this in a human readable fashion. It is too much detail here to bog you down unnecessarily. I'll draw on a piece of paper. Is that top you are using correct? It was HTOP, by the way. HTOP, slightly different variation of top. So the question was, what software was I using to show processes? That was HTOP. There is another question. We'll be taking a break soon. Yeah, if you need, I ask for it, I'll give it to you right away. So I'm assuming that you just asked for a break, so I will give it to you. And we just take a short break. And after the break, we'll conclude this content delivery network distribution discussion. I will start a break timer. Here we go, timer, 10 minutes. And I will take a break.
Hey, Nilesh.
Yes.
So you were saying that my website had a permission problem?
Yes, I suspected. Maybe if you don't see the problem, there is no problem. But I saw a problem, so I just said.
What did you see? Can you show me what you see?
I will show you what I see. So here it comes.
Okay.
Okay, Tammy, your link is this. And that's the problem. So your CSS is not loading properly.
Yeah, no, I noticed that too. But, you know, looking at, and I was going to ask you what that was, because Mark's looks really pretty.
I think I get what you're doing. I think what you may have forgotten is to either convert that site convert the bucket into a website.
I ran that command.
Or your bucket level permissions are not public?
I have everyone and I have read bucket permission.
Okay. So maybe I'll take a look at your screen and figure out what's going on. In the meanwhile, try a different bucket. Try a different case, different example.
Okay.
So yeah, like your bucket name is Timmy B, so try something else.
No, I know this sounds kind of dumb, but could it be my index.html file is kind of out of whack, because I know I had problems getting that to work right, get it uploaded. And...
Yeah, I can actually tell you what may be the problem. I'll give you some pointers. So here, look at my notepad. Right?
Okay.
Compare with what Mark has with what you have. Right?
Yes.
And so let's go do comparison. On the line number 1, or rather 4, it is you, right? And on line 7 is Mark. Now let's compare the URL. Your URL bucket name is here, whereas Mark's bucket name is here.
Oh,
so
okay.
That is the difference. So let's go put that let's go copy this line number 4 and rewrite it a little bit. So go here, dot, and you don't need the index HTML actually.
Okay.
And so in the case of Mark as well, you don't need that index HTML. And let's go see if you open Mark's website correctly. So I'm going to take line number 9, put that in a new tab, and it opened up nicely. Now let's go try line number 6 for Tammy. And I rewrote the URL a little bit, as you saw, 4 and 6, the difference. And I'm going to open 6. And it opens access denied. So there is some problem in the permissions situation. That's what I can tell. So that is what you should examine. So there is some structural difference in the way your URL has to be structured like this in order for the website permissions to open. This is accessing only the index file, not the associated CSS JavaScript elements.
Okay.
And that is the difference between 4 and 6. So you look for a way to do it like 6. That should solve the problem.
Okay.
HTTPS versus HTTP.
No, it's not that HTTPS is a case, but let's go see. So without the S, it's still the problem, right? It's still a problem, whether HTTPS or not, it's still a problem. So the problem is, I think, bucket permissions. It says access denied because your access is denied to other objects that are in your bucket.
If I brought up my bucket and shared my desktop, could you look at it?
Yes, I can.
Okay, give me a second. Let me do that. Because, I don't know. Let's see. Internet Explorer. Oh, let me grab my keyboard here. Amazon services. My account. Okay, I'm going to get ready to share my desktop with you here.
Okay.
Where am I? Not that one. Okay, share screen. Share screen. Let me know when you can see it.
Yeah, we see it.
Okay. So here is my bucket. Okay, and then do you want, let me approve that. There you go. It's all yours.
Okay, let's go check permissions. And so we want to get everyone to be able to list objects.
Okay.
Oh, okay. And Public access, S3, everyone to be able to list. Nice. Now, what else we have here? Tammy can do whatever she likes, and everyone can list objects and also read objects. So that was at the bucket level. Let's go item level. And all these items, we would like to get their permissions to be public. So make public.
Okay.
And we are going to make everything inside public. And so it is doing that recursively. And now go to the properties tab and say website hosting. And here is the link.
Oh, okay.
And it's opening up nicely now.
Oh, it's way prettier. Thank you.
Done.
All right.
Okay.
Thank you for that. I was going to ask, I know. The question I was going to ask you, when you were talking about, this kind of made me a little bit nervous because you've mentioned it a couple times about making sure that we do not put our access key and secret key so that hackers can get it.
Yes.
Yes. But how did that? Did people upload that to their bucket, and that's how they got it?
No, not in the bucket.
Okay.
People who kind of halfway know Git will accidentally include their credentials in Git commits and push it to GitHub because they do not realize that they're doing it, and that's how most accidents have happened. And,
okay, well, I just want to make sure I don't do that.
I will don't. So I think it happens in the second segment. That's when it happens.
Okay.
The DevOps segment. That's where we'll start using those things heavily. And that time I will again abundantly caution everybody. And it's no issues. I will make sure that it doesn't happen to you because I have trained myself to prevent that from happening.
Okay. So. All right. Well, I appreciate that. I don't want to get no big bill.
I will prevent that from happening by giving you abundant warnings and caution so that we don't make mistakes.
Okay, great. Well, thank you for helping me with that.
You're welcome.
Appreciate it.
So I am now walking away from the computer for a minute, and I'll come back just
Thanks.
I'm going to release control and watch the timer, how much time we have. Okay, we have 1 minute. Oh, I need to rush. So I'll be back. Hey guys, I am back. And okay, timer is pinging. Let's check if everybody else is back. Hey guys, are you back?
Yep.
Yeah, people are walking in. I can see some of you guys still walking in. So I am getting ready to draw another picture. And still making sure that people are here. Not here yet. Not everybody is here yet. And I'm going to start projecting. And
I'm back. My video's just not working today.
thank you. No worries, no worries. So I will now draw this idea that I described to you, which was the idea of, first of all, live streaming. This streaming is happening through a protocol known as HLS, implemented in Macintosh and Edge browser in Windows. Macintosh and iOS and Edge. The open source project that we use is called Nginx RTMP, which is the backend server that receives the stream. Now, what we need to do is make sure that we have a source. And the source this time is not a bucket. It is not a website, but it is a camera that is able to stream video, like as it shoots. So that's what I just did with my iPhone example. I have a camera, which is a source, and it is going to stream RTMP protocol, HLS stream, and it needs to go to some computer. That computer needs to run this application, Nginx RTMP application, or it can run Adobe Flash Media Server, commercial product. And that is where the reception from the camera is received. Now, once it is received, it can then rebroadcast it to any location you want. So you have a web browser that is either an Edge browser or a macOS Safari browser. It can play HLS live stream if you have the browser pointing it to a RTMP server. And that's the scenario that you begin building. However, this is your small, tiny machine that you might have. And this is your iPhone camera as an example. You can have bigger cameras, other things also in place. Now, if you have lots and lots of these kind of browsers connecting worldwide and trying to hit your small little tiny little box, this box will die, and you don't want it to die. That's the whole purpose of putting a CDN layer around your box. So what we want to be able to do is, you have a streaming source, let's call it the source. This is your HLS server, the live streaming server that you have. So you take from the source, give it to the server. This server is now able to stream out. It is able to stream out, but you don't want to load it up. So what you do is put a cover around it, our CDN cover, a CDN distribution. In case of Amazon, they call it an RTMP distribution. So you can go and see that. The example that they show you here is in case of Amazon. Where is Amazon? Here. They give you RTMP distribution. That's what they call it. Other companies will call it something else, like here they call, the name they use is enabled for HLS, optimized for HLS. So here we have the zone setting set for optimal HTTP live streaming. And that's what you are basically going to make use of, one of those services that will provide you a layer of content delivery network that is able to continuously receive from the source as it reaches the origin server, your HLS server, and all those bits and pieces of streams coming out. You want to capture them and provide that to the end users worldwide, wherever they are, in whichever locations they are. But make sure that these people don't hit your box directly, because if they do, your box will die. And so you want to avoid that. And how do you do that? You simply use a CDN and remove all these entries completely. And all that streaming that happens directly from the box, you let that be taken care of by a content delivery network, which is capable of streaming HLS RTMP traffic. And then have these users, global users, look at their local point of presence, and that is where they will receive that RTMP stream. So each one of them will be happy in terms of the performance that they perceive from the live video feed coming to them. And the underlying idea behind this HLS protocol is that it lets you excuse me it lets you adjust according to network bandwidth available. So something like this will be feasible. I'll open up an example to show you an idea. So signing in a quick example to bring up, which is the authentication code I want to grab. No, I want to grab the authentication token. Token, please. Off you go. And where is my token? There it is. So here is the token and enter. And now I'll open up a piece of code that will help us understand what this HLS protocol is doing from a usage perspective. So where is that? Not here. So what this protocol is capable of doing is, let's go see some examples. Drawing by hand. I cannot quickly find it. So what happens is if you have a low bandwidth network, let's say places in India, so those guys will receive 640 by 480 video. Places in Seattle, they will receive 1080p video. And this transition will automatically happen, and it will automatically downsample and give the appropriate video feed to people in rural areas in India which do not have high-speed internet, compared to people in Seattle will receive a full 1080p 1920 by 1080 resolution video delivered to the same from the same server. And that is the beauty of HLS protocol, is it adaptively streams appropriate quality of video depending on your bandwidth. So this HLS endpoint that may be a CDN endpoint in turn in your proximity location will automatically detect what resolution is going to be making the user happy with the video performance, even though the quality is a little bit lower compared to here is high quality. This is not so good, not HD quality. You can see those things, transitions happen on its own as you receive the traffic coming from a CDN, which in turn is receiving the traffic from your origin server, which also needs to be a streaming endpoint. And this server needs to receive traffic from a streaming source. Something like the example I showed you, an iPhone example. iPhone by itself doesn't actually stream, by the way, just so you know. I have put in an application that actually does the streaming for me from the camera I have. So just native iPhone does not stream by itself. You have to add an app that will enable it to become a source that you can then send it to a streaming server, which you put a cover around your content delivery network, which will then automatically adjust according to available bandwidth, adjust the resolution and send the appropriate signal quality to the recipient without slowing down the video. If you keep sending high quality video to a person with a low bandwidth connection, they will suffer buffering, which is not exactly a good thing. You would rather deteriorate the quality of the video and keep video motion smooth. That's the idea behind HLS streaming. And that was a quick example of two different cases where your underlying technology used is this, which is HTTP live streaming. And I showed you an example of the service provided to me by KeyCDN and also Amazon. So in a nutshell, content delivery network takes the load off your server, puts it outside in a globally available network, makes your users happy, and gives you a bill. Just remember the bill part. You will receive a big bill if you have lots of users and lots of content flowing through the network, but for low usage, pretty cheap. So scale accordingly and keep an eye on how much are you spending. So that's the important thing to remember. Now let's go different type of storage solution. There are lots of different types. We discussed two of them up until now. So S3 primarily, and then put a CDN wrapper around on top of it. Let's go understand the EFS scenario. What is this thing? And so if you recall the discussion from the last time, if you remember, I mentioned there is this thing called object store, and there is another thing called a file store. And a file store is very, very simply something that you may have used already umpteen number of times. You probably use it every single day. And that will appear to you something like, a NAS in your company, network attached storage. You probably know this already. A network attached storage in your organization will look something like, you may have seen it showing up as SMB:// G drive in your company, for example, where you have documents sitting, and that's where a particular file .doc will be. So that's a SMB protocol representation of the G drive sitting in your company, where everybody in the company can access that particular file object. That's how typically NAS is created, network attached storage. If you're an Apple company or using Apple computers, you will probably have a protocol like this, AFP:// again, G drive, same thing. If you are a Windows person, you will likely see this example, compared to a Macintosh person will likely see this protocol, the AFP protocol. If you are a Unix or Linux shop, you will see a slightly different variation to the same thing. Basically, these are different protocols answering and addressing the same file content, the file.doc file, or file.docx file to be specific in a Microsoft Word scenario. You're accessing the same file object through multiple protocols, the Microsoft protocol, the Apple protocol, the Unix protocol of network file system, Apple protocol of Apple filing system, and SMB, which is server message block protocol from Windows, from Microsoft. They're all accessing the same exact file object through different methods of access, different operating systems, but accessing the same file system, a network file system. That's what this NAS thing is. And you may have seen this in your companies. Remove the G drive and put something else into that place. But that's what you must have seen it already. In your homes also, you can also access things like this. If you have a Windows network and lots of Windows computers, you will be able to see something like this in your home setup. / my other PC / pictures / cat.jpg, something like that. You can access a remote cat picture in a different computer, which is your other computer, my other PC computer, through this method. That method of storing stuff is called network attached storage. You've seen it in your home examples, company examples, and a very famous home usage open source product that I suggest that you play with is this thing called, FreeNAS. If you happen to have a box that is sitting around doing nothing, you should install this operating system directly on the box, and it will give you a beautiful, highly available, highly resilient, fault-tolerant storage system for your home usage, which also, by the way, the latest version includes object store as well. This is free and open source, and it has ZFS, and it can handle 2 hard disk failures at the same time. If you have like 6 or 8 hard disks in your FreeNAS box in your home, and I have been running it for the last 15 years like this, I have tolerated 2 concurrent hard disk failures while my family members are comfortably accessing the cat pictures. No problem. And that's the beauty of that product. It is solid, rock solid. Nobody seems to be commercially talking about it too much because it is open source. So there is no money to be made. So companies don't talk about this, but I'm just telling you, look at this product. It's rock solid, better than any other storage solution. And it is Unix based. So FreeBSD based, basically. Having said, there are companies that provide NAS solutions. Big ones are EMC, NetApp, and these days, this guy, EFS. Where is the guy? We just saw it. Amazon is doing that. In the context of cloud, this guy, EFS. So let's go there and see what they do. What they are doing is creating a file system in the cloud. What does that mean? It means something like this. You have a place to store your pictures, your objects. That's the object store, which is known as SSS, also known as S3. And that's the bucket that you create, and you put your object there, and it's accessible to anybody from outside directly through the object store access system that you just played with as an exercise. Now, the other idea, which is the EFS idea, is not a bucket structure, but it's more like a file system available to all these machines out here. The one I'm deleting, they all will be able to share a common network file system. Let's call it EFS. That's what they have used the name. And this file system will be commonly shared among all the machines that you will have in your application in the Amazon cloud. By the way, this is specific to Amazon. Other clouds do not have it yet. So you can add more computers like that, and they all will be able to access the same shared pool of files. What does this translate to? This storage is a file-based storage available to all these machines that you grow and shrink and create and destroy. They will all be able to access the same set of files, just like this structure, like I mentioned, any of these protocols. Most of the time, it is not this, but this protocol. It is the NFS protocol, which is extremely popular in Linux land. And that is the protocol that I think this guy provides it for you. It is basically an NFS storage. So if you now create a file system, what does that mean? It will basically put a file system and make it available in multiple zones, if you like. So you can select which zones you like and which one you do not. Put that in your virtual private cloud. And in the next step, it will just magically create a file system for you that you can access through your applications running in your boxes here and wherever they are in that cloud, in your virtual private cloud. Now, under the hood, what's going on? What is exactly going on? Let's go find out. If you look at a project called Gluster, it's an open source project and now owned by Red Hat. They manage and maintain it. And what is this? It is a free and open source software scalable network file system. And you can install it very simply by following these steps. So there are ready-made solutions available. You can run it simply and it will give you a network file system. So this is the underlying technology that Amazon seems to have. I don't know for sure, but apparently this is the technology that they use under the hood here in EFS. Now, how does that technology play out? And we'll actually play with the technology ourselves without, so we can take it to other clouds. That's the core idea. Since we know that this EFS solution is currently available only in the Amazon cloud right now, but I want to still have the benefit of using a shared file system for all my machines here and here. I would like to have that benefit in other clouds, even though I may not be using the Amazon cloud. So I need to create something as I build out my cloud setup. I need to structure it in a fashion that it is allowing me to use a network file system as I grow and shrink the number of machines that I have here. These machines that I have here. So I want to be able to grow, add more, reduce some, add some, and all of these machines should be able to access a shared file system. Now, some of the challenges with shared file system, as you already know, is if this machine seems to be writing or saving a file, the picture of cat, for example, .jpg at that moment in the file system, then it is locked up by other machines, cannot access it at that time. So there has to be a method of lock and release. Just like file systems provide. If you have a file that you open up here in the command line, for example, you will see that, let me show you an example. So here, I have this file, let's say index.html file here. I can open it up. And once I open it up, this file is now logged for editing by this process, so other processes cannot really open that particular file. That is a contention created by design in the file system so that other people do not destroy the file. And that is called file locking, simply speaking. We want to be able to enable that kind of a locking setup so that one process that is currently dealing with that file locks that resource until it is done doing with anything with whatever it is doing with that particular file, and then it releases the lock. And once it is released, other people, other machines, other processes can actually access the same resource once the lock is released. And that's the underlying idea. To enable this in just any cloud you like, you need to have Gluster enabled. What is that Gluster thing? It is basically a piece of software that you install on each of these machines. So you install Gluster here and here and here and here. And then you have to have a method defined that you allocate a piece of disk storage here and a piece of disk storage here and a piece of disk storage here and a piece here. And you call these bricks. And these bricks continuously interact with each other through that Gluster software and are able to provide a common file system for each of these machines out there in your cloud. What does that boil down to, translate to simply? It gives you a shared file system for you to use and at the same time allow you to get rid of a machine or bring it a new one or add more like this. And you can grow and shrink as you like, and your Gluster file system will grow and shrink as your needs grow and shrink. At the same time, maintaining the file system state. So whatever files you save, whatever files you delete, you rearrange, you organize your file system, it will be exactly the same way for every node in your application, in your given deployment. So that makes it easy for you to write your applications and scale out or scale back in your cloud configuration for a given application at the same time. At the same time, remember, keeping your state of the user outside of the machine, right? So you are able to do that by keeping it in a network file system, pretty much like this. While doing it this way, storing it in a GlusterFS or storing it in Elastic File System like Amazon provides, you're essentially what you're accomplishing is dependency on any one of these boxes. You're not dependent on a single one of them, but you are basically collectively dependent on the whole set of them. And therefore, you can then make sure that you can get rid of these boxes as and when you feel like, or bring them more of them as and when you feel like, and thereby giving you the ability to grow and shrink. That's the fundamental idea behind that Elastic File System discussion that we just had. And that is what this will create. If you need to have an application to hook it up into, so there's nothing to do in the next step. I can go next step and I can proceed through. And here I can create a file system, but I cannot use it without having to have access to a set of machines. So if I go back, you can choose, there are two types here. Choose the performance mode. General purpose is the default. You can choose higher performing I/O by selecting faster disk and more bill. This means max I/O means a little bit bigger bill. General purpose is good enough for most applications unless you have a very high intensity I/O per second requirement. You can choose that parameter here in Elastic File System, and then you basically next step and configure that file system. The file system becomes available, and there is no charge on it. There is no bill accumulated unless you actually use it. That's the beauty of this file system. So you can create it, but there will not be any bill unless you put stuff in it. So as soon as you put stuff in EFS, they will then start charging you money on a per use basis. So EFS pricing is also very similar. EFS pricing is very nicely structured. You can see the pricing of Elastic File Systems. It is based on a per gigabyte basis. So in US East Virginia location or any of the US locations, you are spending 30 cents for every gigabyte every month. So very cheap price that way. So if you're storing a gigabyte of picture objects in your file, so I should not call it objects. If you're storing a gigabyte worth of pictures or files in your file system, you're spending 30 cents. That's it. There are no bandwidth charges, no request or read or write request charges, no nothing else, because it's all inside your VPC, inside your cloud. There is no other cost apart from storage. So you pay 30 cents, you get 1 gigabyte of storage for 1 month of usage. You use it, and then that's pretty much it. That's how the pricing is. So if you use less, you pay less. If you use more, it's a good solution to have. It's a ready-made solution. You don't have to worry about Gluster setup yourself. Setting up Gluster can be daunting a little bit if you want to make it grow and shrink along with your infrastructure. So that is what we'll do in another exercise. In fact, this cloud machine that I have in that website that I run is actually in Gluster. You can see that right here. So it is in Seattle, and it is actually mounted in a Gluster file system. But again, right now it's a small setup, but it is ready to grow as people will add on and pile up more traffic on the box. If the box CPU consumption goes higher and stays longer for a higher duration of time, right now the CPU percent is very, very low because not many people are there on the website. But if it gets a lot of traffic, it will detect that there is a need to grow the machine set. It will automatically add more nodes. And of course, on top, we have a CDN cover. So it will take care of the performance problems as such. But the machine set will grow and shrink automatically. That's how this EFS or Gluster scenario is used. I just actually, in my discussion, mentioned a thing that I don't think I have yet discussed, which I think is worthwhile discussing. So I will describe that idea. That idea is something very important to understand. And it is about scaling. I keep mentioning about maintaining user state outside your machines. And I talk about scaling, but there are two distinct ways you can scale. Scaling can mean grow or shrink. Both can mean scaling. So now let us see two different ways that people scale. Two ways. They grow, they shrink. So they do it in two different ways. One simple way is like this. I have a box and I need one more, so I get one more. That is called scaling, right? I grew. I grew. So the example was I am growing, GROW, and I'm growing outwards. If I grow more, like this, then I am growing out further. I'm growing out and increasing the number of machines I have. If I go the other way and I start shrinking, then I am scaling back in. So the word choice is very careful here. So we are scaling, we are scaling out and we are scaling in. Scaling out is growing this direction, and scaling in means shrinking this direction. That's one type of scaling. There is a second type of scaling that is we haven't discussed yet. So I will describe that now. This was scaling out and scaling back in. The second type of scaling that I think you should be aware of, you probably know this intuitively, and that is not, I haven't discussed it yet, so I should call it out. So here is the box. I am going to scale it now like this. And it became a huge box. That is also scaling. This thing is called scaling up. And if I make it small, again, this thing will be called scaling down. And scaling up and down is slightly different in the way that you look at this example. I hope you got the scaling in and out versus up and down distinctly clear. I am going to show you an example of how do you scale up and down, which I haven't actually described to you in a real example. So if you go and look at DigitalOcean, create a droplet, for example, here we go. And there I can potentially create a droplet, a machine that I want to construct. So I can select a machine as small as $5 per month, 512 MB RAM. And now if I want to grow up, scale up, what do? I click here, or maybe here, or go all the way here. That is how one can scale up. If you want to scale down, you shrink like this, like this. You still have one box. You're scaling it down, making it smaller. That's the idea here in scaling up versus down. You take the box, you grow it up, and you shrink it down. That's one type of scaling. This is useful in certain cases. It is not the dominant way of scaling in the cloud, but it is a valid way of scaling. The dominant way of scaling in the cloud is this way. So you need more machines, you get more machines. You'll need less machines, you shrink them. That's the dominant pattern, in and out versus up and down. So those are the two different types of scaling patterns that you will notice. And people are very particular in choice of words. The out and in means the size remains the same. Up and down means the number remains the same. The size might change, the number may not. Whereas in here, the number changes. In here, the size changes. That's the idea that I want you to understand and be clear about, the scaling idea, because people can randomly say, oh, we scaled. That may not be a good idea to just scale from $10 machine to a $640 machine, because you just increased your cost 64 times from a $10 per month to $640 per month, and you have 1,000 boxes. It's a 64 multiplier for price of cost of the equipment infrastructure on a monthly basis. May not be a good idea. Instead, you could increase the number of machines you have by keeping them small size and maybe get 10 of them. You get 10 $10 machines, you're spending $100 per month, and you get 10 boxes decently sized with 1 GB memory each, as opposed to just one box, 64 GB memory. It can be expensive. So it may be needed for a specific type of application usage scenario, but not always the right one. So growing up and down is not necessarily the only way. The dominant way is this way, is most people scale in the cloud this way. Now, which are the applications which require this kind of a scaling up and down? It is when you have a lot of need for CPU. Need of CPU. Lot of CPU consumption is needed. You can get a lot more CPU here because it is giving you how much? 20 CPUs right there in this example, right? So you can get a bigger box if there is a need for high CPU consumption, lots of mathematical calculations. If your application demands it, you need to get bigger boxes. And then I think even then you should scale it out. Get a couple of big boxes, and if you need more, you get one more big box. So you still scale out. That's the kind of scaling I want you to remember, is that these two variations are critical to understand, be aware of, and then apply judiciously as you go along. There is a chat question. Non-parallelizable computation. So yeah, correct. That's a scenario where you get a up scaling, where you cannot really, this outscaling is not possible in that application. Where Travis is suggesting is that you have an application that cannot be really parallelized. Don't use the word parallelized. I tend to accidentally say that. So parallelizable application. If something cannot be parallelized, you are forced to get a big box. In most cloud usage scenarios, it is easy to just spread it out across multiple machines. And that's not parallel computing per se, but it's just distributed computing. So you have different boxes running the same thing for different people, different end user endpoints. And that's the dominant usage scenario, where people like this will hit the load balancer and then get hit here. This guy will go to here, and like that. They'll spread the load, spread the workload among multiple boxes of small size, maybe medium size, and get the job done. And then you can easily grow and shrink, as long as, remember that one more time, which is you are preserving your state. Preserve the state outside somewhere. Outside, as in either in a bucket or in a GlusterFS or in an Elastic file system or in a database somewhere here, any of those places. So you have to put your data, your relevant context of the user state, users generated content, their login information, their signing on, their cookie, any of those things, you have to keep it outside these boxes. You will be much better off. In fact, it will allow you to scale out and scale back in and on demand, and save money and service customers at the same time, keeping them happy. So that was a brief on our EFS discussion. The third type of storage is right here. Go back a step. And here. And there it is. It's called Glacier. Amazon calls it Glacier. Now, if you remember, some of you may have seen this idea, which is called tape drive. Some of you may remember that. Like, I don't. So I don't think you know it. But there is this thing called tape, which apparently is, I have never seen, but yeah, I know some of you may have. So some of your companies probably still use tapes. The tapes are used for archival, long-term data retention. And these are, magnetic tape storage. So let's go see some pictures for those of us who have not seen it before. So tape storage looks like this is a good example. There are lots of tapes, and you file them in an automated system. It knows where a particular file is, in which tape is stored, and that's how a tape storage system is retained in a long-term archival storage. It is cumbersome, time-consuming to grab the right tape and load it up in order for you to be able to access the items stored on that tape archive. It is painful, but required by law sometimes to store and archive data. So that's what people use, tape archival. But this is archaic technology. So what Amazon and Google and others have done is implemented a very similar structure. In fact, they call it nearline storage. And nearline is basically, as Wikipedia describes it in a picture somewhere. Where is that? Where is the picture? Yeah, this picture is good. So this is a good picture. And so here it is describing something like this. So they call it Google Nearline Storage. That's the name of the product by Google. It is Nearline. It competes with this product from Amazon called Glacier. What do the products do? What they do is provide you with a method of low cost, extremely low cost. Right? It's cheaper than S3. That is something that is like 1/3 of the cost of S3. So cheaper than simple storage service, cheaper than your bucket storage, and give you a very long-term archival. So if you create a vault, you have to choose a region, give it a name, and then load up that vault. This vault is basically a place to store stuff for long-term archival. The challenge with this is that the retrieval part is expensive, which is what apparently how Amazon has designed the pricing. So if you think about that idea briefly, imagine if you have an island, and in that island there is water all around, and there are these alligators all around it, and you are in the mainland here, and you want to go to the island. So there is a boat that takes you, and this boat will go to the island. And by the way, going is free. Coming back is not. And that's the idea behind Glacier. Is going there is cheap, but retrieving data from it is going to be slow and expensive. In fact, I think the retrieval policy for Amazon Glacier is like you have to ask for the data and wait 3 hours. Ouch, I don't like it. And that is the benefit that Google has created for themselves in here, is that the time to first byte, the moment you want your byte back, the time to first byte is very, very similar to the time to first byte you would get in an online storage, like a bucket storage system, but the price you pay is 1/3. So if you pay 3 cents for the online storage, like a bucket storage, you would pay 1 cent for the nearline storage. This is like a cent per GB per month, I think. So that's the pricing. And compare that with offline storage. The time to get the first byte out of the system, recover, restore, retrieve is going to be long. So like 10 to the power 4 seconds. Like maybe it's some large amount of time, depending on the service provider. So if you go read Glacier retrieval, so I should say AWS Glacier retrieval, and let's see how they recommend that we retrieve. So if you go read their FAQ, the retrieval options, data retrieval policy, what do they say these days? Yeah, retrievals are slightly differently priced. The time, the way to retrieve is you have to actually make an API call. There is no browser interface to get the object back from the archival storage. That's another drawback. And there are expedited retrievals available if you need it quicker, which will charge you more money, and it will be available in 1 to 5 minutes. That's an expedited retrieval, which is also slow. But just realize that it is a cheap long-term archival. So if you want to store it here, that's a good option for data retention and archival and legal perspective. It is actually a very good solution for a long-term. Just dump it there and forget it, and maybe recover it 30 years down the road when the government wants it. Something like that. That's the kind of scenario of usage for archival in Glacier. And a better alternative, according to my reading, is this nearline storage from Google, which is much better compared to what these guys provide, simply because it is quicker to retrieve. And so here you have redefining archival cloud storage. And let's see the value proposition these guys claim. And let's go to the consoles. That's best. I just log in and see what's going on in that under the hood. And so here is your storage solution for Google. And I can create a bucket here, and that bucket can be nearline. So here I can store the data for nearline storage, and I call it my archive. And then put it in a nearline storage. So used to store rarely accessed documents, best for data accessed less than once per month. And then you have another option called cold line, which is basically, you don't access it directly. You have to ask for it and get even slower, but even cheaper. That may be more relevant depending on your usage patterns. So they don't have differently named products for the same thing in Google. They just have the same item called a bucket in which you put objects, and then they have a class of service different. So for example, the last time we used the example of multi-regional bucket, and I gave it a name here, something like Travis, something I said. And that was a bucket that we used in a multi-region location where it is serving streaming video or host hot web content. This hot means hit, doesn't mean hot. It means hit. Which is readily available, frequently accessed, kind of hot. And so that's the multi-regional location. So the class of service in storage in Google, the nomenclature is different. And in Amazon, you see the names used such as, they'll call it a completely different product called Glacier, which is what their choice of words is. Whereas in case of Google storage, They don't have a different word for these things. They just have a different class of service. It's still called a bucket, but you can put that bucket in multi-region or just in one region, or use it in nearline storage, once a month access, or cold line storage, really low access. And then you can choose the region you like and create the bucket and specify some labels. And accordingly, the pricing will fluctuate depending on your class of service. So they don't have a different name for the product that they provide. Just by the class of service, it is a bucket. So it doesn't really matter what the naming of the product is. It's more about the class of service, the way you use, the way you pay for it, how much you pay, and how frequently you do not access. Like access less than once a year per month. Once a year, that's it. So that's cold line storage, very, very low access, very, very cheap. And under the hood, what these companies are doing, I don't know, but I heard is that they, at least Amazon has used their optical storage disks and older computer systems over the years. They have put that in this kind of a usage where the machines are slow, but they are working and functional. So the mainstream users are not using those equipment that have been accumulated and have been basically outdated. They have repurposed those hardware in form of Glacier, and they just give that as a storage solution for a throwaway price. They know that the machines are cheap, so they can offer a very, very low price and get away with it. That's the underlying technology apparently these guys have apparently implemented. Again, I have not seen it. They don't let anybody in there, but that's what I hear from people that I know in those companies, is these technologies are coming basically from that point of view of usage patterns. So now, closing out on storage ideas. So basically, it boils down to service levels from an object storage perspective. How frequently do you want to access? How globally distributed availability do you want for that particular object? So even in S3, like you saw in case of Google, where you saw a multi-regional bucket, in case of S3, you can choose to create a bucket that is in a region that you like, but they don't seem to have a multi-region concept. So this bucket is strictly limited to a particular region. You can choose to be in Sydney or Frankfurt or London or Oregon or one of those places, but Amazon doesn't seem to have that idea of a multi-region bucket that is best for data access frequently around the world. They don't have that setup.
Hey, Nilesh.
Yes.
So how often do you use like buckets with, say, instances from a different provider? Is that a sensible thing to do ever?
I think I want to rephrase your question. The question I think you have is, can you use bucket from Amazon and a machine from another company?
Right.
Is that what you want to ask?
Yes.
The answer is yes. Of course, you can. And I'll show you a live example. I do it all the time. I mean, here it is. I think I showed it to you already. And so let me just show that. I think that question is a very valid question. The question is, let's go focus on something. Line number 9. This item is sitting in Vultr Cloud, line 9. The content delivery network equivalent of the same item, line number 9, is line 17. It is sitting in a European CDN called KeyCDN, and it is globally available. So it doesn't really matter whether it's European or not. But that's line number 17 is a CDN representation of line number 9, which happens to be Vultr Cloud in Seattle. Another example, okay. Line 11 is in Vultr Cloud, and line 24 is Amazon's CDN of the same object.
Okay, but what about for data that is not accessed directly by the client? What if for stuff that's actually involved on server side computation or something like that, like a database?
Aha. So this is about database data, not about a picture, for example, or a JavaScript file or a CSS file. So it's not a static item. It is a dynamic data, right? The dynamic data is not covered by content delivery networks. And so how do you optimize the performance of that data? I will show you that example. But it is not about storage, by the way, because it is about databases. So databases as a service is a different scenario. Let's quickly look that up right here. So in here, you will see that they have a separate category of those things known as, so like storage services here, they have a different category of database services. And in there is where you will store dynamic data, like a user logged in, user's password, their credentials, their credit card number, any of those details will belong in the database in the back end. Now that data has to also perform quickly, efficiently, globally. And CDN is not the solution for that. So what is it? So there are some solutions available from all these companies, and we'll go look at some of those examples now that you bring it up. Let's go look at the first one in database segment. First one is RDS. What is that RDS thing? Let's go check. RDS is basically relational database service. It gives you access to a globally, I should not say globally, it's highly available multi-region, no, not multi-region, highly available multi-zone solution of database from Amazon. Now let us go get started. So click and we'll find some choices available here. What are the choices? There are 4 or 5 of them. One of the most commonly used ones is this, MariaDB, or which is basically, compatible with MySQL. Both of these are open source products. Another one very extremely popular is this database called PostgreSQL, also open source. And I think one of the best databases you can get is this. People also use Oracle and or Microsoft and all that, but those are commercial. We are not talking about that. This is the best, according to me, and open source. And it has better pedigree than any other database that you can think of. And so we'll talk about databases later. But for right now, you can select any of these databases. And this Aurora is a MySQL and Postgres compatible databases, but customized by Amazon. So they are pushing it. That's why it's the first choice available. But people like me will go here or here or here, depending on what their needs are, and set up a database. So when you do that, let's say select a MySQL database and select that, click. And so you can choose to have this run as a test setup, which is not what our intention is, not for production. So we'll not go that route, not going this route. Instead, I will go this route. So production usage. Now here I can deploy this in multi-availability zone deployment and provision it with high IO per second storage on the backside. So higher performing disk. I'll choose that option and click next. Now here I can select that my license is GPL for the open source MySQL database. I can choose the version number of the engine that I want to use. So I can choose the latest one if I like. And then I will choose the machine that will run it. So I can choose a very, very small machine, or not good for production because very small. So I'll choose maybe a M3, M4 large. That's a good machine size. And then I need to select multi-availability zone. So I need to put this database across more than one machines, 2 different locations, 2 different availability zones. So I need to select that and say yes. So give me the same thing in multiple availability zones. And we'll talk more about availability zones in maybe in a few. So hold on, but I need to add some hard disk here. So I'll say 100 GB hard disk, and then I select my database identifier. Here I can say my database, like that. I can choose my user and my password and my password again. And now I have configured my database connection string and put my database on a M4 large box available across multiple availability zones. And then I go next step and I configure where do I want these things, in which virtual private cloud, in which subnets, and all those details. We have to provide that, and then choose the software, the login, the password, and the key pair. And then we construct a method of backing it up every 7 days, every so often, enable a method of monitoring it if you like. So we can select those. We'll also choose to whether automatically upgrade the underlying MySQL database or not. And do we have to provide a maintenance window? If you want to select a specific maintenance window, you can select that. And then you launch the database service. When you launch that service, Amazon will maintain this MySQL database for you, back it up every 7 days as you require, and make it available across 2 different availability zones. That's this deployment model of using a database as a service. Now, this is different from you running a database on a machine yourself. You can do that, by the way, and it's going to be cheaper, yes. But then you are supposed to be responsible for maintaining the database and its replication across another availability zone, and making sure that it's available and resilient, and performance is good and all that. Now, answering your precise question, how do we make sure that it gets cached? The dynamic nature of the data in flight being more responsive than it would otherwise be if it is going to be just the database. What is that CDN equivalent that you can put around so if you have this database server and it is running on its own, you need to provide a layer around it so that its performance is improved. What is that thing? It is not a content delivery network. So what do you add here that will make its performance snappier? That's the real question I think Brian wants to ask. And the answer to that question is 2 open source projects. There are 2 of them. One of them is Redis. And it is this project. It is a memory cache. So if you read the description here, it's in-memory data structure used as a database cache, or just as a cache, or a message broker. So 3 ways of using it. And that is one of the open source projects that I like. The other one that is also very dominantly used is called Memcached. And this is also a similar distributed memory object caching software, also open source. And both of these technologies are actually available right here in the Amazon cloud as a service. They call it, it's a different name. What is it called? Elastic something, Elastic Cache. So right there. Here in the database segment, you have this item called Elastic Cache. So if you go click there, find out what they provide. It is basically a layer around your database, which will expedite and keep the data in flight in memory, in the RAM, as opposed to going all the way to the hard disk. If you keep your live data in the database data in the RAM, it's a very highly effective and highly performing solution for a database system. And those 2 technologies, Redis and Memcached, are the ones that are under the hood on this service called Elastic Cache. So let's get started, click on it. And what you will see, the 2 choices that I just mentioned. Do you want a Redis cache or do you want a Memcached? So you pick and choose whatever you like. And in Redis, they have also started this cluster mode scale out operation. So you'll have multiple large RAM machines available to cache the data in flight between your database and your end user. And it will be caching in the RAM on a Redis cluster. And that is what will be set up. So you can give it a name, give it a description, and engine compatibility version number, port number, and off you go basically. And you select your VPC, select your subnets like this, and deploy. That's it. When you deploy, you connect it back to the database that you might have yourself, or the database as a service that you might have taken from this particular cloud. And then you have a higher performing database solution cached by an Amazon Elastic Cache cluster running Redis on the back. That improves the performance of the live data flowing between the user and the database. It's a separate layer, differently structured, uses RAM, very large RAM machines running Redis software, and this is a ready-made service. Since in my example, in here, I am not running on the Amazon cloud, so I have a Redis service running myself. So Docker stack ls, and you will see that in this stack, I have a Redis service running. So Docker service ls. No, I think Docker ps should show us that. So here you will see there's a Redis service running right here. And it runs on the port number 6379, and it speeds up data access to the database. Let me show a little bit smaller so you can see the whole picture nicely. And I think it's a good question that Brian is asking, which makes a whole lot of sense as to why would you want to know that, because it is a very logical question. So now it is a little bit smaller, but I hope you can still see. So let me do it again. Right there. So you will see the first item is a load balancer. The second item is the WordPress site that you see running. Actually, the third item. The fourth item is the Redis server, or rather I should say a Redis container in Docker. All of these are Docker containers, by the way. There is a MariaDB database running in a separate container. And that MariaDB, the interface between you as a user and the MariaDB on that container is interfaced in between by the Redis layer. And that Redis is what shows up in a cache when you log in as an administrator on this site. On the back end, you can see that the cache is deployed and shows up in the performance section of this site where you can see it. And I'm going to go to the exact location to show you where I'm using Redis cache right here. And it is for page caching, it is for minification, it is for database caching. I'm also using Redis right there. And you can go and test that database cache and validate whether the database cache is actually running. This is basically the same Redis host that I have with port number 6379, and I'm going to test it. And it says testing passed. So what I'm doing is basically testing my Redis connection between the database and the user. And what you're looking at is this Redis cache helping out the MariaDB container. And that is my local cheap implementation because I do it myself. I'm able to, many people do it this way if they know what they're doing. Most companies, though, tend to use solutions that are available to them by companies like this. So they tend to use these solutions because it's hassle-free. Just go get started, use their solution, and off you go. It is going to be costing you money, but when you know the thing, you want to do it yourself. That's what I end up doing. So I build it myself because I know how to go make it happen. So I do it all the time. But there are commercial solutions available from these guys, and almost every cloud will give you such a solution like that. So to help you make your database performance better. There are four more different types of excuse me, 4 more different types of database solutions we'll discuss at a later time. I want to close out on the storage discussion for right now with a couple of things to remember, that we want to now jump onto the network capabilities of the cloud. And that is where I want to bring up this reminder for you, where I would like you to just watch a bunch of videos, 1 2-minute long, and a series of them, about 13 or 14 of them. And I'm going to give you a link to that so that you have it handy. And that is the homework. It is very simple. Just watch videos. And so I will identify that homework for you. And it is going to be short videos. It's going to be clumsy and somewhat creepy to look at, because you'll know what I'm talking about when I show it to you. I think you must have seen it, some of you. So creepy. Begins here, and the video starts in that segment. Creepy meaning my head shows up in a creepy fashion. That's what creepy means. You can see the creepy guy right in the corner, that guy. And so I'm going to paste that link in the Slack chat right there. These are short little videos. There are about 13 or so of them. Please watch it. And I know it'll be hard if you have never done this, but don't worry. To give you an idea about what these things are, I will give you some background so that it will help you digest this content. It will not make sense. Let me tell you already. It may not make sense to you as to what is going on unless you do it. And doing will be another challenge. So I will do it for you next time. But right now I'm giving you some overview of what this thing is and how does it play out in the overall picture. So back here on a sheet of paper. And okay, so grabbing a full screen and drawing it out. What we intend to do is that this Amazon cloud or any other cloud will be big, and we want to isolate a segment for a given application, and that's what we really intend to do. So what we are doing is establishing a private area inside our account in the big Amazon cloud or big any other cloud, a private subsection. And in that, you should think of as if it is your home office away from office, or home away from home, or something else. But it is yours. It is private to you, just you, nobody else, but it is away from you. That's the core idea. Now, that is what is going to be referred to as a VPC, virtual private cloud. It is private, it is yours, it is a cloud. In this cloud, it is virtual, meaning it is not in your data center. It is VPC. That's what we will do, we'll play with, and that's what that exercise, the series of videos is about. In that VPC, it's basically you have to have all the things that you will typically have in a home setup. What do you have in a home setup? You have an ISP, internet service provider, like Comcast or Quest or one of those guys. Any of these guys will give you basically what? An IP address. IP address where? In a modem that they provide. That's what you typically get, right? This is your public IP. That's what you will receive even in your VPC, is pretty much similar to what you have in a home setup, conceptually, not actually, just concept. You have a modem. In the VPC, it will be called a gateway. That's what it will be labeled as. And in there, you will have to have a segment or a LAN network, local area network. In a VPC scenario, they will call it a subnet. And you will have multiple LAN networks, multiple subnets, like this. Multiple subnets for different things in your home, away from home, in your VPC. For various things, you will have multiple network subnets. What do you do with these subnets? You will put computers here, like that. And so, in effect, you will have one subnet, second subnet, third subnet, more subnets as you go, like, and you will have machines here, operating, doing different things. And some of these subnets will be in a different availability zone, a different location, a different building, where you have structures pretty much similar, but a different availability zone. You will have such structures like this. You will also have some of these subnets connected directly to the modem that you have from Comcast, or the gateway that the VPC will provide. Some subnets will let you connect directly. You will also have a thing that you have in your home. It's called a router. And yes, you will have a router in one of these subnets, in one of those availability zones, and another router in another availability zone. What does this router do? These routers, they will allow your home computers, like these guys, and maybe here and here. These are not directly connected to the machines, to the modem and going outside, but they connect through the router. All of them connect through the router, and the router then connects to the world outside. That's the scenario. That's what you will see in that video series. That is what is going to build out a VPC. That's what you're looking to go through in that series of videos, that you will understand. You understand it already. Just realize that the whole thing is going to be in the context of a large cloud, where you segregate a small area. Doesn't have to be small, an area, and you carve out these subnets, and you put machines in those networks and connect some of them directly and some of them through a router. Just like you do in your home. You have a laptop that you do not connect directly to the Comcast or Quest modem, but you put something called a router in between. That is exactly what is needed in a virtual private cloud. You have to have a router, also known as, I should say, in a VPC scenario, it will be called NAT device. It's basically a router. It's a NAT, they call it NAT, so whatever. I'll describe what that means and why they call it NAT and all that, but it's a router. And so some computers you might have, this computer number 1, computer number 3, they will go through the NAT and then go outside to CNN.com or YouTube or things like that. And some other machines like the C2, you may want to actually do a test and say, you know what, I don't want to use the NAT router. I just want to fix my Comcastic connection, but doesn't seem to work. So I will sometimes connect the computer directly to the modem. And that is going to be a troubleshooting step. Sometimes you do that. Some other cases, you will notice that this NAT that you have or the router that you have is also a computer, by the way. You know that a router is basically a computer. This router that I'm looking at right now is a computer, this one. And so I need to make sure that this router itself is directly connected to the modem outside. That's a necessary step. That's how a NAT device is supposed to be connected directly to the modem, and so that you can then connect a computer to it and have the traffic flow through the router. So remember that these are the concepts that I will be discussing. Other concepts will be subnets. More other concepts that you will see in that video series, short video series, will be about routing table, subnet associations, things like, I think if you have not done these things, don't worry. If you know what these network technologies are, and if you understand subnets, routing, route tables, mapping, associations, and flow of traffic, you need to tell me that you already know, so I will not bore you with stuff. I'm assuming that you have not actually hands-on worked with networks yourself, even though you might have connected your home network, which is a good thing to have, but you may not have dealt with software networks like we are describing, software-defined networks like we're discussing. And so if you have experience, I need to know that. So please tell me. And that is what we intend to go over in the next time. So please watch this video. That will help you understand me somewhat better. I know this is the hardest segment in our cloud technologies portion. It will take some time for you to completely understand. Without this understanding, it will be hard to proceed in the next set of things that we will do. So that's why I'm cautioning you, to please understand this. It is more important to understand than anything else, because it'll be a stumbling block. You will get stuck. You will not figure out what's going on. And I'll close out with one simple discussion, which is about a thing which is called security group. Security groups is a collection of firewall rules. And we'll discuss it a couple more times with various examples and hands-on exercises for us to get the idea. So security group is a collection of rules. A rule is basically, it's a traffic rule. So what is okay to travel, what is not okay to travel, that is what is defined in this collection. That's what you will see. So a simple rule will be something like this. My laptop in my home should be allowed to travel to CNN.com. So that's the router. A rule should be in place. It's, by the way, already there. That kind of rule is already placed in the router that says any computer inside the home should be allowed to visit any site on the internet. That's one of the rules, by the way, in the router. And so that is a firewall rule. And so in your virtual private cloud, as we go along, you will have to construct this rule, because they don't give you anything. There's no such thing as predefined rules. So set of rules, you have to call it out. What is okay? What is not okay? Which traffic should be allowed? Which traffic should not be allowed? You need to decide that. You need to write that down in form of simple rules. That traffic from here should go there. Traffic from there should not go here. That is the kind of set of rules that we need to put together in form of rules that are collectively called, in case of Amazon, they call it security groups. Other people call it different names. Like in case of Google, they call it firewall. Simple. In case of Google, they have simpler names. They just call it storage for all the services that they have. They don't have different names for S3 and Glacier and things like that. So simply firewall. That's what they use. We have to understand firewall rules and apply that to our own example, because nothing is given to us to begin with. We have to build this virtual private cloud ourselves from scratch. And that is our plan. So with that understood, what I would like to ask you is, let me see if I can, hold on, let me adjust. Where is the recording screen? There we go. So what I'm doing is I'm basically stopping to record and ask you this other question, which is, where is the recording button? Here. So I'm stopping recording.